Hello everyone. As you know, my name is Shubham, and in today's session, we're going to discuss about the collection framework hierarchy. Okay, so the hierarchy is defined based on the classes we have. Okay, so this hierarchy are basically classified into two parts, which is collections classes hierarchy and the map classes hierarchy. Okay, so before discussing about today's topic of discussion, let us focus on some of the questions related to the previous class. Okay, so in the previous class we discussed about the hash table and the properties class. Okay, so the first thing which we are discussed is the hash table. So in this respect to your hash table, the question might going to become like, what is hash table and why should we not use it? Okay, so the first thing which is that what is hash table. So for this question we have already discussed in yesterday's class, so you can refer to my previous video for answering to that question. Okay, so this question you can use to to define what hash table is, and also the different properties we are available with, or different factors available with your hash table. Okay, so moving further, coming to the second part of our question, that is why we should not use it. Okay, so in this aspect we have already discussed about this thing which is similar to that of your vector class, that is your hash table class is a synchronized class. So whenever you're trying to use this hash table class in a multi-thread environment where you're not modifying the data inside your hash table, okay, the single hash table, so in that condition, when multiple thread acted on this object, it reduces the performance of your hash table, and hence because of this poor performance, we are nowadays mostly don't use this hash table class to store the key and value pair, that is entries. Okay, moving further, next question, that is what is main benefit of using the properties file. So we have discussed about this properties file also yesterday. So that is storing your key and value pair outside the Java class, that is inside a text file. We call it as an we just created one text file which is abc.properties file. Okay, so this file is just a text file. Inside this text file we define this key and value pair in this format, that is key equals to value. Okay, and whenever you want to retrieve the value for this key, you can go to the Java class. So okay, so to read that file we were using the file reader, and to load that file to your properties class, first we are creating the properties class object. Then with the properties class object load method, we are passing the file reader to this load method, and from this you are getting the properties text file inside your properties object. And with the help of this properties object dot get property method, okay, so in this get property method you need to pass the key for which you want the value to retrieve. So with this you are getting the value out from your properties file. So the one main advantage, so according to this question, what is the main benefit of using this properties file? So one main benefit I'm talking about this is this benefit, that is whenever you do any modification in the properties text file. So in general condition, whenever we do any modification to your Java class, what we need to do is that we need to recompile that file to use that modification. But in case of the Java class where we are using the properties value by reading it from the properties class. Okay, so in this condition, whenever you're modifying any value of your properties text file, so to recognize this modified value, you no need to recompile your Java class. Okay, so this is the one of the main benefits we are getting from your properties file. Okay, so there's two questions we discussed today, that is what is hash table and why should we not use it, and that is the second question is what is the main benefit of using the properties file. Okay, so considering this your um, first Java version, that is Java 1.0. So why these collection classes are called as the legacy class? Okay, so these classes we are having the most of the deficiencies in the Java 1.0 classes. Okay, so like we are not having any generics for this. We These classes were synchronized classes. So because of these classes, because of these things, these classes were not used much of in use nowadays, and hence because these classes are not much used, we are available with the new classes with the better versions. So as these classes are not available, but still Java need to provide the availability for these classes were put into the legacy version, that is the old versions. Okay, okay, so because of this reason also, this usage of this legacy classes is also not suggested. Okay, so this was about the related to our Java 1.0 collection topic and its related interview questions. Okay, now coming back to our today's topic. Okay, so which is 7th of today is the 7th of November. Okay, okay, so in this today's topic of discussion, we will going to discuss about the collection framework classes hierarchy. Okay, so what are the different classes available with us up to the latest version of the Java, and how these classes are modified in the collection framework? So we are going to discuss about this thing. Okay, so in this Java 1.0 we are available with the only 5 classes, but they are not sufficient to satisfy our needs in Java collections. So we are available with the different other updated classes in the Java collections with the improved facilities to work with this object storage. Okay, facilities. Okay, so moving further, we are okay. So in basic, I'm going to discuss about this hierarchy up to the date point, that is up to this Java 14, the hierarchy we are available with. I'm going to discuss about this. Okay, so first thing is that we are available with this one interface, which is iterable interface. Okay, iterable interface is the what we can say super interface for the collections related classes. And yes, so collections related classes, and then we are, wait a second, recording. Okay, so this iterable interface is the super interface for the collection related classes which are available in our collections framework. So this collection framework divides its classes in basically 2 parts. One is collection type classes, and another is in map type classes. So this collection type classes stores the object in its index format. Okay, so this stores the object without having any identity. But if you are considering the second part, that is second part of the collections framework, which is classified, is based on the map. So in this map hierarchy classes, the objects are stored with its identity. That is, it is having the key and value pair, that is entries. Okay, so we are available with this two categorization of the collection framework. One is collection type classes. Okay, and another hierarchy is the map type classes. Okay, so collection type hierarchy stores the object without identity, and map type classes stores the objects with having the identity. Okay, so we are first going to discuss about the collection type classes, and in this collection type classes, iterable is the super interface for the all classes available inside the collection hierarchy. Okay, it is not the root interface, but it is a super interface for all the classes available in there. So below this interface, we are available with the second interface, which is collections interface. Okay, So this collections interface is the root interface for the all collection classes available inside your collection type classes. So this root this collection interface. So let me just put I here. So I have to tell that this is interface I. Okay. So this uh, let me put one more thing. Okay. So this is the sub interface of your iterable interface, and collection interface is the root interface for all the collection related classes. This class contains the basic okay, so this class is provided for us to provide a basic or super hierarchy for your collection related classes, that is to the collection classes which is storing objects without identity, and it provides some of the basic methods which we need for processing your storage of object without identity. Okay, so the objects, the all the classes in this category. Okay, so basic operation we need to perform on them. For this, the methods are available in this class, okay, in this interface. Okay, and this interface is again categorized these classes into three types, and these three types are list, set. Okay, so let me start with set interface classes, then list type classes, and then queue type classes. Okay, so this collection is again classified as classes according with set implementing classes, list implementing classes, and queue implementing classes. So why was there this categorization is happening? So this categorization is happening because, okay, so the object we are storing, it can be a duplicate object. Okay, so if we want to store the duplicate object, in that condition we can use the list. So list allows us to store the object in the duplicate manner, that is the same object can be repeat multiple time in your collection object set. Okay, so set does not allow us to store the objects in the duplicates. That is, if this same object is again add to your set implementing classes, so in that condition it won't going to accept us. And queue is there to store your object in the first in first out order. Okay, so this categorization based on the first is based on the uniqueness, second is based on the duplication, and the last one is in based on the its order of storing. Okay, so let me just do this. Okay, first one, second one, and third one. Okay, so moving further, okay, we need to provide the implementation classes for this hierarchy interfaces. Okay, let me put I here. Here also I, and here also I. Okay, so yes, so to store the object in the duplicate manner, we are having the list interface. Okay, but it is okay, so it is having the method specific to the duplication or the storage. So the basic methods we need, the basic operation we want to perform while storing this object in the duplicate manner. For this, the methods which we need is defined inside the list interface. Okay, so for this, methods are defined inside this list, and this list implementing classes. Uh, okay, so we are having the basic four classes which is implementing your list, and these classes are vector class, tag class, array list class, and the linked list class. Okay, so before, okay, so before going further, I want to tell you one thing, that is we are also available with one abstract class. Okay, one abstract class, which is abstract collection. Abstract collection. Okay, so this abstract collection is implementing this collection interface. Okay, so as I told you that collection contains the basic operations or basic method which is common for all the classes in this collection hierarchy, but we need to provide the implementation for this method which is declared inside the collection interface. Okay, for that we have two options, that is we can define these classes in the collection class, sorry, a concrete class or an abstract class. So what is the difference between this defining this method inside this two? Okay, so first thing is that if you are defining this method in the concrete class, you can create the object for this class. But if you are defining this methods inside of abstract class, so you cannot create the object for this class. So with that same intention, Rackup people, what they did is that they provided the implementation of that the methods which is defined inside the collection interface inside this abstract collection, so that people won't going to create the object for this. Okay, and to inherited this implement this defined method, for this we are okay, we are having the different classes. So as I told you that list is having the 4 implementation classes. Okay, so this 4 implementation classes are vector class, okay, the stack class which is subclass of your vector, then we are having the array list, and then we have the linked list. Okay, so these are the classes available with it. So because of the limitation of how I can assign these classes, let me go to the diagram part. Okay, so I'm going to share a diagram with you people so that you can look at this diagram and understand the basic hierarchy of the collection related classes. Okay, so can you see this diagram? Okay, can you see this?
Oh, yes, yes.
Okay, so as I told you that iterable is the super class. Okay, so super interface for your collection related classes. Okay, so it was made that super interface in the Java 1.5. I would also describe the changes made with respect to the Java version also. So this Java 1.5, this iterable class is made the super interface for the all collection related hierarchy classes. Okay, so then we are having the collection interface, which is the root interface for your collection hierarchy classes. Then we have this set in set implementing classes, list implementing classes, and the queue implementing classes. Okay, so one more thing I have told you, that abstract collection. So why this abstract collection is given? Okay, this abstract collection is implementing collection interface. So this abstract collection is given so for us to provide the implementation for the methods which is defined, common methods which is declared inside this collection interface. Okay, and the abstract is there so as to stop the user from creating the object for it. Okay, so like I told you that collection contains the sum of the method and provided the definition in the abstract collection. Likewise we are having some of the methods. Okay, so this some operation which is specific to list also. Like this we are having some operation which is specific to the set implementing classes, and likewise we are having some of the operation which is specific to the queue. So these specific interfaces must also provide some of the related operation method declaration inside its interface. So list contains the list specific interface. Okay, list a specific operations declaration. Set contains the set implementing classes related common method declaration. Likewise queue contain the common method declaration for the queue implementing classes. Okay, so this implementing this declarating class declarating methods, we need to provide the implementation for this method. So where I can provide the implementation for this method which is declared inside your set, list, or queue is one more abstract class. Okay, so this abstract class is there for the same purpose as we are taking the abstract collection. That is, we don't want to create the object for this. We just want to provide the implementation for the common methods. In that case, we are having this abstract set where we are defining the concrete method for the method declaration available in the set. Likewise, we are having the abstract list to provide the method implementation for the method declared inside this list interface. And like this, we are having the abstract queue. Okay, so yes, as I told you, that list contains the four classes. Okay, so this hierarchy is mostly updated in the 1.2 version. After the legacy class were not much of use. Okay, and in 1.5 version also we are available with the generics. So according to these generics, I have also specified the generics which we are using along with the class declaration, like here element E. So E represent for the element you are trying to store. Okay, so list implementing classes, so we are available with the four classes implementing your list interface. That is, this classes can store the objects in a duplicate manner. Okay, the first class is a vector, which is a legacy class which we have discussed in the earlier sessions. You can refer to the my previous video YouTube links, YouTube videos to refer to this class description. Okay, and yeah, second class which we discuss is this stack class also, which is in subclass of your vector, and it stores the object in the last in first out order. And third class, which is array list class. Okay, so this array list class is differing from our vector and stack in a manner is that this class is not a thread step class. That is, it is not, its methods are not a synchronized method. So this okay, so because of which the poor performance we were getting in the vector class because of the multi-threading environment when we are executing this. So this limitation is excluded from your array list and improved. Okay, so then we have this another class which is linked list class to solve the problem of the insertion element in between your list object, which is reducing performance in case of the array list, because it needs to do a lot of shifting when you try to store the object or it want to retrieve delete the object. So it needs to do a lot of shifting of this objects inside the list. To solve this problem, we are available with the linked list. Okay, so linked list is it's a list of nodes which is combined with each other with the node addresses. Okay, so this linked list implementing, okay, two interface. One is this abstract, okay, so one is the list interface. Okay, and second is this DQ. So this class implementing is having the two interface implementation. One is list and another is DQ. Okay, so this is collection, sorry, queue hierarchical classes. So why is it so? Because this linked list can also provide us with the first in first out order operations, because for this purpose we are linking our linked list class to the queue interface. Okay, so we discuss about this list implementing classes and why we are available with this abstract classes also. Okay, so this list which stores the heterogeneous, unique or duplicate.
Shubham, hello.
Yeah,
Hello, Shubham.
this is
We are using abstract list because array list and vector stack, these are the subclasses of the abstract list. So it contains its own specific classes also. So that's why we are abstracting it from the abstract list. Now, that is the only reason, or any other
the
reason also there.
abstract list main purpose is to provide the implementation for the common method which is
Okay.
specific to the list
Yeah,
related
yeah.
operation. Okay, so
Okay, yes,
we
yes.
need to provide the this implementation in any one of the classes. We can provide this implementation in the vector class, we can provide this in the array list. But if we are doing that, we are making that definition specific to the vector, but this operation are specific to the list, all the list implementing classes. Okay, so for that we need to provide in a class, okay, where we can extend it from the all classes of the list implementing classes. So all this list implementing classes is directly or indirectly extending from this list, abstract list. Okay, and this abstract
Yeah.
list
Okay.
contains the
So
definition
what you?
for. Okay, got it.
Yeah,
Okay.
I got it. But so the thing is, the definition is the definition is same. Like the definition is in the abstract class only, but the implementation for the for the subclasses like vector and array list, these are specific to its class, right?
No,
That is only you want to
this
say, na?
definition is in list. Implementation for these methods are available in the abstract class. Definition and declaration, I'm using these two words. Okay, declaration means the just I'm declaring.
Okay.
Definition means declaration and the implementation part.
Okay.
Okay, so this implementation is provided in this class abstract list, and this all this operation, common operation which are implemented in the abstract list is consumed by all this classes. Okay, this all these four classes. Okay, common operation is consumed by all these classes which is defined in the abstract list. Okay, like if I want
Okay.
to.
Okay. And the
Yeah,
okay.
yeah. Okay, so let me
Yeah,
put
tell
you
me.
put in example. Okay, so as to have you better understanding, like if I want to implement an add method. Okay, so here I'm having the declaration only. Declaration means um, public object add, and in brackets object parameter. Okay, and semicolon lastly. We are not having any implementation for this. Okay, so if we are providing the implementation for this add method inside our vector class. Okay, so okay, so same thing we need to do in the array list also. That is, we need to also provide here also the implementation for the array list, and here also linked list also I need to provide the implementation for the add method. But if you are doing the same thing in multiple classes, it is provide creating the boilerplate code. Okay, so when the codes are same, okay, so the implementation are same, we are putting it in the a super class. Okay, and we are extending
Yeah,
our
yeah, yeah.
classes from the.
Actually,
Yeah,
actually, I understood this point before only,
okay.
but I was telling like add method is okay. Add method is having the common logic, so that's why it is defined in the abstract list, right?
Yeah, yeah,
But if the array list there is a difference between vector and array list. So
yeah, yeah,
definitely there is a difference.
yeah,
That's
yeah,
that's why we use the
yeah,
in real time we use this. So what I want to ask you, like, there should be some method, na? Like array list is having some of the methods,
yeah,
but the
yeah.
vector is not having those
Yes,
methods.
yes,
So
exactly.
that only yeah, yeah, yeah. So that we described and that we define in the array list only, na? So that was I'm asking,
Yeah,
like,
yeah, yeah, exactly. You're right. Every class is having its own specific methods also. Okay, so like vector is having some of its own specific logic. Array list is having some of its own specific logic. Like this linked list is also having the own specific logic. So this abstract class is only providing us with the common methods. But if we are talking about this specific classes, this specific classes is also having its own operation, which this class is only doing. Okay, for its own purpose, and in that condition each class is having its own separate method also, which is differing from the other classes. Okay, so yes, we are done with the list implementing classes. So I'm just describing the basic hierarchy today, and from tomorrow onwards what I'm going to do is I'm going to show you the each implementing classes in detail. So for this, so yes, okay, so we are done with the list implementing classes hierarchy. Then we are coming with the set interface implementing hierarchy. Okay, so who's there? Okay, okay, no, okay, you're welcome, Noor. Okay, so yeah, coming to the set implementing classes. Okay, so why we are having the set interface? The first thing we need to understand is list is storing the objects, heterogeneous or unique objects, in a duplicate manner. But we, in some cases, we want the object to be stored in a unique manner. Okay, so in this condition, when I want to store objects in a unique manner, So for that, we are using the set interface implementing classes, and this set interface uh, is having some of this its own specific method declaration, and for this method declaration, we are providing the implementation in its abstract set abstract class. Okay, so we are having this main four classes, which is state implementing classes. Okay, so I want to make sure, okay, I want to clear one thing here, is that the classes I'm showing here might not be the all classes available in the collection hierarchy. Some of the classes might extra classes might going to be there, but as this class the extra classes is not having the much of an importance in the actual programming, that is they are not used much in your programming. So I'm not going to use these classes, like when you are going to see the map hierarchy classes now. So in that condition, we are having a lot of classes. We will not going to discuss about it. Only four classes we are going to discuss about the map implementing. Okay, map categorization classes. Okay, so the important classes which we use in the daily regular day-to-day operations, we are only going to discuss it. Okay, so yes, set implementing classes. So we have this so set implementing classes, which is hash set class, linked hash set class, which is a subclass of the hash set class. Okay, then there is tree set class and enum set class. Hash set stores the object in a unique manner. That is, whatever the object you are trying to store must be single object in that collection class. Okay, so whenever we try to store the duplicate object, it won't accept like this. But the problem with this hash set is that it is not maintaining any insertion order or any kind of order. It is just randomly storing the object. So in the if you are going to print the object details, okay, so you're going to find that the object it is storing is not having the any order. But if you want to specify the insertion order for the object you are trying to store inside the set implementing classes, for this we are having this linked hashtag. So hashtag is not preserving any order, but linked hashtag store the unique object in the insertion order. Okay, so to store the unique object in the insertion order, we are using the linked hashtag. Okay, now third class, which is enum set class. So enum set is there. Okay, so enum set is introduced in the 1.5 and linked hashtag is introduced in the Java 1.4. This version also you need to remember. Okay, so enum set. So if you want to store the objects, okay, and that object is enum const. Okay, you want to store the group of enum constant in a collection class. So in that condition, if you are trying to store it in the hash set or a linked hash set, is giving some of the reduced performance. To give a better performance, when you already try to store the enum set, okay, enum constant. So in that condition, we are available with one more class, which is an enum set class, which stores the enum constant uniquely. Okay, and the fourth one class, which is tree set class. So the unique object we are trying to store in your set implementing classes, if you want to have the order for this, like the ascending order, descending order, like you store the student list, you want the list to be in the ascending order according to its first name, or descending order according to its first name. So for this, if you want to provide the order for that object we are trying to store in the set implementing classes, we are available with the preset. So it stores the object in the ordered manner we provided. So order, it can it the in default it stores the object in that object's natural order. Second thing is that if you don't want that natural order, we can store them by using our own comparator, where we can define our own sorting logic. Okay, and second thing is that the key set only stores the comparable object. So that object we are trying to store in the tree set must implement the okay, so must be of comparable type. That means it must implement the comparable interface. Okay, and it only accepts the homogeneous element. So you cannot store the heterogeneous object inside the tree set. Okay, so to provide the navigation between the elements which is sorted in this tree set, for this we are available with this tree navigable set interface, which provide the methods to navigate between the sorted element. Okay, And to sort this element in your set implementing classes, we are available with this sorted set. Okay, so this is sorted set, not a sorted set. So this sorted set interface is there to provide the method to sort the elements inside your tree set object which you are trying to store. Okay, so moving further, our third interface of the collection hierarchy, which is queue interface. Okay, so if you want to store the object in the first in first out order, like the in the stack, what you are doing is that we are storing the object in the last in first out order. But if you want to store the object in the first in first out order, so in that condition we are available with the queue order. Okay, so queue interface. Okay, and we are available with the one of the other interface which is extending from the DQ. If you want the operation this iteration, okay, from first in first out, or the or first in last out, if you want this double order, okay, so in that condition we are available with the DQ interface. Okay, so yes, like this, to provide the common method implementation, we are available with the abstract queue. And lastly, we are available with this priority queue and the array queue. Okay, so priority queue stores the object according to its natural order element. Okay, according to its natural order, though this the object we are storing, okay, the unique object only. Okay, unique object, it is having some natural order, like ascending order is most of the time the natural order, natural order for that for any element. Okay, most of the time, but it does not means it is compulsory that object must have the natural order as an ascending order. Okay, so it stores the element, priority queue stores the element or object according to its natural order. Okay, but if you don't want the natural order, for this we are available with the also comparable interface, comparator interface. With this help of this comparator interface, you can store the elements in any order you want. Okay, going further, we are available with the DQ. Okay, array DQ. So if you want to store the element as a first in first out, or last in first out, so in this condition, if you want the better performance than the, okay, so if you want to store the elements in the first in first out order and you want the better performance than the linked list, so in that condition you can use the array DQ. Okay, so this was about your collection hierarchy classes. Okay, so we discuss about these two things, which is collections classes, collection framework classes are divided into two types based on its so the in one case the objects are stored according to its index format, that is without having the identity, and one case where the objects are stored with having the identity. So with having the identity class is the collection framework classes, which is categorized into the map implementing classes. Okay, so aside from this, we are available with this some of the cursors to iterate between the elements inside the collection object. So what do I mean by iterating is that I want to retrieve this object. Okay, so how I'm retrieving the object from my collection objects, based on this retrieving procedure, that is iterating procedure, we are available with the different interfaces or implementing classes to retrieve this object. Okay, some of these classes are enumerator, which is defined in the 1.0, and it is also legacy version. No one use it for the new classes. Then we are available with the iterator. Okay, so iterator is mostly used nowadays. Okay, previous days, we cannot say nowadays. uh, okay, it can iterate the element in only one direction. Then we are available with the list iterator. Okay, so it can only iterate the element in the list implementing classes in both direction. Okay, so the iterator cases, we were only able to iterate the element in one direction, but if you want to iterate the element in the two direction, we are available with the list iterator. Okay, so then we are available with the again other methods like stream API is available with us. This split iterator is available with us. They are both from the 1.8. Then we are available with the for each loop and the for each method, which is there in the 1.5 version. That is, for each loop is there in the 1.5 version, and for each method is there in the 1.8 version. Okay, So this was about the collection hierarchy classes. One more thing which I have not discussed, that is iterator. Okay, so this iterator which I told you just now, which is introduced in the Java 1.2, is inside this iterable interface. So this iterator interface can be used for all the correct collection hierarchy classes. Okay, so you can use this iterator for all the collection hierarchy classes to iterate the element or retrieve the element from these classes. Okay, okay, let me change my screen. Okay, so we are done with the collection hierarchy classes, collection type classes. Now let us go back to our map type classes. Okay, so for this, wait a second.
Shubham,
Yes, yes,
hello.
yes, yes.
You are covering map type classes now only today only.
No, I'm just giving just overview of what classes are there. So from tomorrow onwards, I'm going to discuss each and every class in detail. Okay.
Okay, okay, no problem. Go ahead.
Okay. So this class's architecture is only 5 minute description, nothing more than that. Okay. Let me open it. Wait a second. Where is this class? Okay. Can you see the class?
Yes, yes.
Okay. So in map type classes, we can store the objects with having the identity. Okay. Like means to provide the identity for an object, we are using the key. So this combination of key and value, we are calling it as an entry. Okay. So in map hierarchy classes, we are only available with this three classes. Okay, not the only three classes, we are available with the lot of classes, but these three classes are main classes. Okay, so one more thing, one more class is there, which is in enum say enum. Okay, so enum map class, which is also important class. Okay, so this map interface is in root interface for your all the classes, which is storing the object with having the identity. Okay, so like in the key and value format. Okay, to store the element. Okay, so store the entry with having the key and value pair. Okay, for this we are available with this one class, which is an hash table class, which we discussed in the yesterday session. Okay, so yes, so this class is not showing here, but yeah, it is in the hierarchy. Okay, in this hierarchy it is not showing, but it is there. Okay, a lot of classes are not showing here because these classes are not much of in use nowadays. Okay, so first class within hash map class, which stores the element with having the identity, that is in the key and value pair. Okay, the problem with this hash map is that, like the hash set, it is not storing the element with having some insertion order or some order. So to provide the insertion order for the element we are trying to store, we are available with this second class, which is linked hash map. So this hash map does not store the entries in the any order, insertion order. So to provide the insertion order for the entries we are storing in the map type object, we are available with this linked hash map. Okay, so all these classes are directly or indirectly implementing the map interface. Then third class, which is in tree map class. Okay, so tree map class stores the unique element. Okay, so and while storing unique entries, so this entry, the key. Okay, so the key must be of comparable type. One thing you need to remember when you are working with the tree map, that class that wait a second. Okay, huh. So this tree map class entry key. Okay, key, I'm talking about the key. So this key must be of comparable type, means that this key object must implement the comparable interface directly or indirectly. And this if you are not having this facility, we can use the custom comparator. Okay, so here we can define our own custom order which we want to provide to the element we are trying to store. Okay, so then we are available with this two interfaces, which is sorted map interface, and then we are available with the navigable map interface. Okay, this sorted map interface is same as this that of the sorted set, that is to sort the element which we are trying to store in the tree map. Okay, so and this navigable map is there to provide the iteration, okay, to navigate between the sorted element inside your tree map. Okay, so with this we are done with the uh, all all collection hierarchy classes overview. Okay, so how we just discuss about the overview of how these classes are there in our collection framework hierarchy, like the collection hierarchy classes and the map hierarchy classes. So we discuss about this. Okay, we have seen the, okay, let me just open the file. Okay, so we discuss about the, let me open the file, collection hierarchy classes, that is collection interface. What collection interface is there, why we are having the abstract classes, what are the different T categorization of the collection implementing classes, set, list, and queue. Okay, so how these classes are defined, for what purpose they are defined, we also discuss about this, and the version. Okay, so the version, you need to remember this all queue related part implementing classes are introduced in the Java 1.2 1.5, and at the same time in Java 1.5 we are introduced with the generics part also. Okay, so this iterable is the super interface for all the collection related classes. And the one more thing is that you need to remember is this collection interface is the root interface of all your collection hierarchy classes, not the iterable interface. Okay, and yes, we are discuss just about the overview of cursor objects, and also at last we discuss about the map related classes. Okay, so we are done with this overview of our Java collection hierarchy classes. So in the next session, means tomorrow's session, I'm going to discuss each and every classes in detail. So from tomorrow, what I'm going to do is that I'm going to start with the list implementing classes, and the first class which I'm going to discuss about is the array list class. Okay, so we already discussed about this. Okay, so we are already discussed about this vector and stack class, and tomorrow I'm going to discuss about this array list class, and day after tomorrow I'm going to discuss about this linker list class. So in each class I'm going to discuss one class in detail with its data structure and the internal working. Okay, so that's it for today. Let's meet tomorrow. Okay, so if you are having any doubt now, you can just ask me. Okay, so related to the hierarchy classes, if any doubt, okay, so if you are not understanding any hierarchy or why this hierarchy is there, you can ask me.
No,
Okay, okay, then okay, so just remember this one thing, important thing. Okay, your voice is breaking. Okay, so the one thing, important thing about this collection hierarchy you need to understand is this collection interface, which is the root interface of the collection hierarchy classes. So we're going to discuss about the what are the methods available in this collection hierarchy collection interface in tomorrow's session also. Okay, so if by chance interview might going to ask you question why abstract classes are there, abstract collection classes there, abstract set classes there. I hope you can just explain this thing to interviewer. Okay. Okay then. Okay, should I start? Okay, so we are done with the today's session. We are going to meet tomorrow. Have a good night.